Niels Bohr, Unlocking the Atom. Learn English through story. What if everything around you, the air you breathe, the water you drink, the chair you sit on, and even your own body was built from tiny invisible particles hiding extraordinary secrets? For centuries, people believed atoms were the smallest building blocks of nature. They imagined them as simple, solid spheres that could never be divided. It seemed like the mystery had already been solved. But one quiet scientist dared to ask a different question. What if the atom is far more complicated than anyone has ever imagined? That single question would change science forever. It would open the door to quantum physics, modern chemistry, nuclear energy, medical imaging, and countless technologies that shape our daily lives. This is the incredible true story of Niels Bohr, the brilliant Danish physicist whose imagination unlocked the hidden world inside the atom. His discoveries transformed our understanding of the universe not by looking farther into space, but by looking deeper into the smallest particles of matter. Yet his journey did not begin inside a famous laboratory. It began in a warm family home in Copenhagen, Denmark. Niels Henrik David Bohr was born on October 7, 1885, into a family that deeply valued education, curiosity, and thoughtful conversation. His father, Christian Bohr, was a respected professor of physiology whose scientific research earned admiration throughout Europe. His mother, Ellen Adler Bohr, came from a family known for its love of learning, culture, and community. Their home welcomed scholars, professors, artists, and thinkers from many different fields. Around the dinner table, conversations often turned into exciting debates about science, philosophy, literature, and the future of humanity. For young Niels, these discussions became an invisible classroom. Instead of memorizing answers, he learned something even more valuable. He learned how to ask questions. Unlike many children, Niels was never interested in showing how much he knew. He was fascinated by discovering what nobody else understood. His teachers noticed that he rarely rushed to answer difficult questions. Instead, he paused. He thought carefully. Then he offered ideas that surprised everyone in the room. That quiet habit of deep thinking would become one of his greatest strengths. Outside the classroom, Niels enjoyed sports, especially football. He believed teamwork and discipline were just as important as intelligence. His younger brother, Harold, shared the same passion. Together they spent countless hours playing, laughing, and encouraging one another. Years later, Harold would become a famous mathematician, proving that curiosity truly ran through the family. As Niels grew older, one subject fascinated him more than any other: physics. He wanted to understand the invisible forces controlling the natural world. Why did light behave the way it did? How did electricity travel through wires? What made magnets attract iron? Every answer seemed to create even more questions. After finishing school, Niels entered the University of Copenhagen, where he quickly earned a reputation for patience, precision, and remarkable intelligence. Unlike many students who were satisfied with reading textbooks, Niels loved performing experiments. He believed nature revealed its greatest secrets through careful observation. One day, while studying the properties of liquids, he designed an experiment so accurate that it won a prestigious scientific competition organized by the Royal Danish Academy of Sciences. The recognition encouraged him to dream even bigger. Perhaps he could make discoveries that would change the world. As the 20th century began, physics entered one of the most exciting periods in history. Scientists were uncovering astonishing new facts almost every year. In 1897, the English physicist J. Thomson discovered the electron, proving that atoms were not solid objects after all. This remarkable discovery raised an even greater mystery. If atoms contained tiny negatively charged electrons, what did the rest of the atom look like? No one knew. Many scientists proposed different ideas, but none could fully explain the evidence. The atom had become one of science's greatest unsolved puzzles. Niels could not stop thinking about it. After completing his doctoral studies, he traveled to England to work with some of the world's greatest physicists. He first joined J.J. Thomson at Cambridge University. Meeting the man who had discovered the electron was a dream come true. Yet something felt missing. Although Thomson was brilliant, their scientific approaches were very different. Niels admired experiments, but he also believed bold new theories were necessary to explain nature's deepest mysteries. He soon realized another opportunity awaited him. One that would change his life forever. In Manchester, England, another extraordinary scientist was making headlines across Europe. His name was Ernest Rutherford. Just a few years earlier, Rutherford had performed a revolutionary experiment in which tiny alpha particles were fired at an incredibly thin sheet of gold. Most passed straight through. But a few bounced backward as though they had struck something unbelievably dense. The results shocked the scientific world. Rutherford concluded that almost all the mass of an atom must be concentrated inside an extremely tiny central nucleus. The atom was mostly empty space. Imagine discovering that a giant cathedral is almost entirely empty except for a single grain of sand resting in the middle. That was how surprising Rutherford's discovery seemed. When Niels arrived in Rutherford's laboratory, he immediately recognized its importance. The nucleus explained part of the mystery. But another enormous question remained. If negatively charged electrons circled the positively charged nucleus, why didn't they simply spiral inward and crash into it? According to the known laws of physics, that should happen almost instantly. Yet atoms clearly existed. They were stable. Something was missing. Day after day, Niels filled notebooks with sketches, calculations, and questions. He walked through the quiet streets of Manchester thinking about atoms. He thought about them while eating. He thought about them before falling asleep. Sometimes he woke in the middle of the night with new ideas, rushing to write them down before they disappeared. Many theories failed. Some worked for only a few minutes before collapsing under closer examination. But Niels refused to give up. He believed nature always followed logical rules. If the answer existed, someone simply had to discover it. Then, another revolutionary idea entered his mind. It came from the strange new world of quantum theory, introduced by Max Planck and expanded by Albert Einstein. Perhaps the tiny electrons inside atoms did not behave like planets moving through space. Perhaps they obeyed entirely different rules. Rules no one had yet understood. The thought was both thrilling and frightening. If it were true, centuries of traditional physics would have to be rewritten. Niels sat quietly at his desk, staring at pages covered with equations. Outside, the world carried on as usual. People walked through the streets, trains arrived at stations, factories produced goods, and children played in the parks. None of them realized that, inside one small laboratory, a young Danish physicist was standing on the edge of one of the greatest scientific breakthroughs in human history. He took a deep breath, picked up his pencil once more, and began writing the equations that would soon unlock the hidden secrets of the atom. For weeks, Niels Bohr barely thought about anything except the atom. Every page of his notebooks was filled with circles, equations, arrows, and questions. He examined Rutherford's nuclear model from every possible angle, but one impossible problem refused to disappear. According to the known laws of physics, electrons circling the nucleus should constantly lose energy. Like a spinning top slowing down, they should spiral inward until they crashed into the nucleus. If that happened, every atom in the universe would collapse. The stars would not shine. The Earth would not exist. Neither would life itself. Yet atoms were clearly stable. Nature was telling scientists that something fundamental was missing from their understanding of physics. Bohr believed the answer might lie in the strange new ideas emerging from quantum theory. Only a few years earlier, the German physicist Max Planck had proposed that energy was not continuous. Instead, It came in tiny packets called quanta. Albert Einstein later used this bold idea to explain the photoelectric effect, suggesting that light itself behaved as tiny particles of energy. Most physicists accepted these ideas reluctantly. They worked mathematically, but they seemed impossible to imagine. Bohr was different. He was willing to follow the evidence wherever it led, even if it challenged common sense. One quiet evening, after countless calculations, a remarkable idea began to take shape. Perhaps electrons could occupy only certain specific orbits around the nucleus. Not any orbit. Only special ones. While traveling in these allowed orbits, electrons would not lose energy at all. They could remain perfectly stable. Only when an electron jumped from one orbit to another would it absorb or release a precise amount of energy. Suddenly, everything began to fit together. The stability of atoms. The strange colors produced when heated gases emitted light. The mysterious patterns scientists had observed for decades but could never fully explain. It was as though thousands of scattered puzzle pieces had finally fallen into place. Bohr checked his calculations again. Then again. Every result pointed to the same conclusion. He had discovered a completely new way to understand the atom. In 1913, at just 27 years old, Niels Bohr published his revolutionary theory. The scientific world was stunned. His model described the atom as a tiny nucleus surrounded by electrons moving in fixed energy levels, almost like invisible steps around a staircase. Electrons could leap between these energy levels by absorbing or releasing specific amounts of energy. Those leaps produced light. Each element created its own unique pattern of colors, its own unmistakable fingerprint. For the first time, scientists understood why hydrogen emitted its beautiful spectral lines. A mystery that had puzzled physicists for generations suddenly had an elegant explanation. Not everyone accepted Bohr's theory immediately. Some scientists argued that it broke the traditional rules of physics. Others admitted, with surprise, that despite its unusual assumptions, it explained experimental observations better than any previous model. Bohr welcomed both praise and criticism. He believed science advanced through open discussion, careful testing, and constant improvement. His theory was not the final answer. It was the next step toward a deeper understanding of nature. As researchers around the world tested his ideas, more evidence continued to support his model. Young physicists traveled from many countries to work alongside him. His laboratory in Copenhagen soon became one of the most exciting scientific centers in the world. Inside its halls, brilliant minds gathered to discuss the strange new world of quantum mechanics. The conversations often lasted late into the night. Questions filled every room. Could particles behave like waves? Could light behave like matter? Could nature truly be as strange as the equations suggested? Among the visitors were some of the greatest scientists in history. Werner Heisenberg, Wolfgang Pauli, Paul Dirac, and Albert Einstein himself. Each brought new ideas. Each challenged the others. Bohr encouraged disagreement because he believed that respectful debate was essential for discovering the truth. His office became famous for lively discussions that sometimes continued for hours without anyone noticing the time. Friends often joked that visiting Bohr meant leaving with even more questions than answers. Yet that was exactly what he wanted. Science, he believed, was not about proving that you were right. It was about getting closer to the truth. In 1922, the world formally recognized the importance of his work. Niels Bohr received the Nobel Prize in Physics for his investigations into the structure of atoms and the radiation they emitted. Standing before distinguished scientists and world leaders, Bohr accepted one of the highest honors in science. But success did not change him. He remained humble, thoughtful, and endlessly curious. Instead of celebrating his achievements, he immediately returned to work. The atom still held many secrets. His growing reputation allowed him to establish the Institute for Theoretical Physics in Copenhagen. It quickly became a gathering place for the brightest young physicists on Earth. Students traveled thousands of miles for the chance to learn from him. The institute was unlike any other. There were no barriers between professors and students. Ideas mattered more than titles. Questions were welcomed. Mistakes became opportunities to learn. Bohr believed that even the most experienced scientist could discover something new by listening carefully to a young student's perspective. His kindness earned him deep respect. Many who studied under him later became Nobel Prize winners themselves. Yet the more scientists explored the quantum world, the stranger it became. Electrons refused to behave like tiny planets. Sometimes they acted like particles. Sometimes they behaved like waves. Their exact positions could not always be predicted. The universe appeared far less certain than anyone had imagined. Bohr embraced this uncertainty. He proposed the principle of complementarity, the idea that seemingly opposite descriptions could both be necessary to fully understand nature. An electron could display both particle-like and wave-like behavior, depending on how it was observed. To many people, this sounded impossible. Even Albert Einstein struggled to accept it. The two men developed one of the most famous scientific debates in history. Einstein believed the universe must ultimately obey precise rules. He famously declared, "God does not play dice with the universe." Bohr smiled and replied with equal confidence, "Do not tell God what to do." Their debates became legendary. Although they often disagreed, they deeply respected one another. Together, they pushed physics to extraordinary new heights. The tiny atom had opened a doorway into an entirely new understanding of reality. But while scientists explored the invisible world of quantum mechanics, another force was beginning to reshape the visible world. Across Europe, political tensions were rising. Dangerous new ideologies were spreading. War clouds gathered over the continent. The remarkable knowledge hidden inside the atom, knowledge created to understand nature, would soon become connected to one of the darkest chapters in human history. And Niels Bohr would find himself facing choices far more difficult than solving any scientific equation. The world was changing faster than anyone could have imagined. During the 1930s, the discoveries coming from physics laboratories were astonishing. Scientists had learned that the atom was not only the foundation of matter, it also contained an unimaginable amount of energy. What had once been a fascinating scientific mystery was becoming something far more powerful. At the same time, Europe was falling into darkness. Adolf Hitler and the Nazi Party were expanding their control across the continent. Countries that had enjoyed peace for generations suddenly found themselves threatened by war. Fear spread from city to city, and millions of lives were about to change forever. For Niels Bohr, the danger was deeply personal. Although he was one of the world's most respected scientists, his family background placed him at great risk. His mother came from a Jewish family, and under Nazi rule, that alone could mean persecution or even death. In April 1940, Germany invaded Denmark. Almost overnight, Bohr's peaceful life in Copenhagen disappeared. German soldiers occupied the streets. Universities were watched closely. Scientists lived under constant uncertainty, never knowing who might be arrested next. Despite the growing danger, Bohr refused to abandon his colleagues or his students. He continued working quietly, protecting scientific research whenever possible. But by 1943, the situation had become critical. The Nazis planned to arrest many Danish Jews, and Bohr's name was on their list. Friends inside the Danish resistance quickly warned him. There was almost no time to escape. One evening, under the cover of darkness, Bohr left his home with only a few belongings. There were no grand speeches. No dramatic farewell. Only silence, fear, and hope. He and his family were secretly taken to the Danish coast, where a small fishing boat waited. The sea was cold. The night was dark. Every sound seemed dangerous. If German patrols discovered them, the consequences would be unimaginable. As the small boat crossed the narrow waters toward neutral Sweden, Bohr remained calm. The scientist who had spent his life studying invisible atoms now trusted his future to the courage of ordinary fishermen risking everything to save strangers. When they finally reached Sweden safely, it felt like a miracle. But Bohr's journey was far from over. Soon afterward, the British government arranged for him to travel to England aboard a military aircraft. The flight itself became unforgettable. For security reasons, Bohr had to wear an oxygen mask during the high-altitude journey. Absorbed in thought, he failed to put it on correctly and quietly lost consciousness from lack of oxygen. Fortunately, the crew noticed just in time and revived him before the plane landed safely. Even during one of the most dangerous moments of his life, his absent-minded concentration on scientific ideas had nearly gotten the better of him. From Britain, Bohr was invited to join one of the most secret scientific projects in history. The Manhattan Project. Scientists feared that Nazi Germany might develop an atomic bomb first. If that happened, the consequences for the world could be catastrophic. Reluctantly, Bohr agreed to help the Allied effort. He understood the danger. But he also carried a heavy burden. Throughout his life, science had represented knowledge, curiosity, and hope. Now the same scientific discoveries were being used to create the most destructive weapon humanity had ever imagined. The contradiction troubled him deeply. He worked alongside some of the greatest scientific minds of the century, contributing ideas that helped advance nuclear research. Yet even while participating in the project, Bohr never stopped thinking about the future. He believed that scientific knowledge could never remain secret forever. Eventually, every nation would understand the power hidden inside the atom. The real question was not whether humanity would possess this knowledge. The question was whether humanity would use it wisely. When World War II finally ended, the world celebrated peace. But that peace came with a terrible price. The atomic bombs dropped on Hiroshima and Nagasaki revealed the devastating power of nuclear weapons. Like millions of others, Bohr was deeply affected. He became convinced that international cooperation was no longer optional. It was essential. For the rest of his life, he spoke passionately about openness, dialogue, and peaceful collaboration between nations. He urged world leaders to share scientific knowledge responsibly rather than hide it behind fear and secrecy. Many politicians found his ideas difficult to accept. But Bohr remained hopeful. He believed that understanding one another was just as important as understanding nature itself. Meanwhile, his scientific legacy continued to grow. The Bohr model became one of the most recognizable ideas in science education. Although later quantum mechanics refined and expanded his original model, it remained one of the greatest breakthroughs in the history of physics. Millions of students around the world first learned about atoms by studying Bohr's simple yet revolutionary picture of electrons arranged in energy levels around a tiny nucleus. His ideas opened the door to modern quantum physics. Without them, technologies we now take for granted might never have existed. Medical imaging, laser technology, semiconductors, computers, smartphones, solar panels, quantum research, nuclear medicine. Even the devices that connect people across continents owe part of their existence to the scientific revolution Bohr helped create. His influence reached far beyond the laboratory. He inspired generations of scientists to ask difficult questions without fearing unexpected answers. He showed that curiosity is stronger than certainty. That progress begins not with knowing everything, but with admitting how much remains unknown. Niels Bohr once said, "An expert is a person who has made all the mistakes that can be made in a very narrow field." Those words reflected the way he approached both science and life. Mistakes were not failures. They were stepping stones toward deeper understanding. When people visited his institute in Copenhagen, they were often surprised by its atmosphere. There was no arrogance. No competition for fame. Only endless conversations driven by curiosity. Bohr believed the best ideas emerged when brilliant minds worked together instead of against one another. Perhaps that was his greatest lesson. Knowledge grows when it is shared. As the years passed, Bohr continued teaching, writing, and inspiring young scientists until his death in 1962. But great thinkers never truly disappear. Their ideas continue speaking long after their voices fall silent. Today, every time a student learns about atomic structure, every time a doctor uses advanced medical imaging to diagnose a patient, every time engineers design new electronic devices, every time physicists explore the strange world of quantum mechanics, the legacy of Niels Bohr lives on. The young boy who once asked simple questions about nature unlocked one of the greatest mysteries in history. He taught humanity that even the smallest objects in the universe can contain unimaginable wonders. His story reminds us that curiosity has no limits. That patient thinking can change civilization. And that one quiet mind, driven not by fame or power but by the desire to understand, can transform the future of the entire world. The next time you switch on a light, use a computer, take an X-ray, or gaze at the stars wondering how the universe works, remember Niels Bohr, the man who looked into the invisible world of the atom and forever changed the way humanity sees reality itself. Because the greatest discoveries are often hidden where no one thinks to look. Sometimes, changing the world begins with asking one simple question. What if there's more to the atom than meets the eye? And thanks to Niels Bohr, we now know the answer. The end.